A sphere has no net. It's relatively easy to imagine that because you can't take a piece of paper and fold it in some sort of way where you form a perfect sphere. The important thing to know is that the surface area of a sphere is 4 pi r squared. And to be able to use this, all you need to do is sub in a value of r. So for example, if the radius here was 4, you would do 4 pi, stick a 4 in there, square it, and then if you wanted to leave your answer in terms of pi, you would just do 4 squared is 16 times by 4, so 64 pi, and then obviously add any units. So if this was 4 centimeters, this is a surface area, so it's going to be centimeters squared. Or if you wanted to give it to an exact number, you would have to stick this in your calculator, which gives you, to 2 decimal places, 201.06 centimeters squared. Again, you don't need to know how this is deduced. There is a method of deducing it, of course. However, you don't need to know that. You just need to know how to use this equation. Occasionally, you might be asked about compound shapes. This is where you take multiple 3D shapes and put them together. For example, here we can see a hemisphere and a cylinder that are on top of each other to form this compound shape. So naturally, you would say, oh, well, just take the surface area of each one and add them together. Let's start off by doing that. The surface area of a hemisphere is half of a full sphere, but then remember to add the circle that's on the bottom, so add pi r squared. So that simplifies down to, well, half times 4 pi r squared gives you 2 pi r squared, add another pi r squared gives you 3 pi r squared. And as we previously discussed, the surface area of a cylinder is 2 pi r squared plus 2 pi r l. So naturally you would add these together and that results in 5 pi r squared because you've got 2 pi r squared plus 3 pi r squared plus 2 pi r l. However, it's important to remember this equation for the surface area of the cylinder includes the top of the cylinder, which you can't actually see in this shape. It's on the inside, it's the circle there. It's on the inside, so it isn't included when we work out the surface area. So that means we need to take away that circle. So we're going to take away pi r squared. But then also, we actually need to take away the bottom of the hemisphere as well, because again, that's on the inside of the shape, so not included in the surface area. So take away another lot of pi r squared, and this will simplify down to, well, 5, take away 1, take away another 1, 3 pi r squared, plus 2 pi r l. Of course, you could factorize this if you wanted to, but because this is a unique shape, there's not really much point in doing that. I would leave it as is. So to work out the area of a compound shape, just take the individual shapes that it's made up of, in this case a cylinder and a hemisphere, add the surface area equations for those two together, or if you want to work them out separately, so if you work out the top one has like 64 centimeters squared, the bottom has 128 centimeters squared, add those together, but then make sure to account for the parts of the shape that are on the inside. In this case, the top of the cylinder and the bottom of the hemisphere.